Hello, my name is Jialing Deng, and I'm here to present our research on sonic delights, exploring the design of food as an auditory-gustatory interface. So our research explores a simple but exciting question: what if food could play sound? Instead of adding sound through external devices, such as attaching an actual speaker to food, we designed food that itself is a speaker, turning eating into an interactive and multisensory experience. In this presentation, I'll walk you through why this idea matters, how we designed an edible loudspeaker, what we learned from our design practices and study, and what this means for the future of interactive food. Our work drew inspirations from the notion of computational food, where food as a material is a medium in realizing computational capabilities. So, why does sound matter in eating? We don't always notice it, but sound plays a significant role in eating. Think about the crunch of chips, the fizz of soda, or the sizzle of steak. These sounds significantly shape how we experience food. Prior research showed that sound can also alter our perception of taste. For example, high-pitched sound can make food taste sweeter, while low tones can enhance bitterness. We found that most previous works and research have focused on incorporating sound into food experiences, such as using external devices like embedded speakers or headphones to play background music while eating. Also, most existing work only used food as additional composites in design, and the experiences of many sound-related food systems have not been fully explored yet. Therefore, we identified a research gap in designing food that functions as a sound-emitting speaker and understanding the experiences it might create. That's where Sonic Delights comes in. We designed a cracker that functions as a speaker, capable of producing audible sound on its own. We expected that as you eat the cracker, the sound plays, but with each bite, it gradually fades. Our goal was to merge digital and sensory experiences in a way that has never been done before. We took inspiration from planar and soft speakers to design our initial food speaker. Our food speaker consists of a thin edible diaphragm with gold leaf attached to it. It is connected to an electromagnet, paired with an additional rare earth magnet and an amplifier. When a digital sound signal passes through the circuit, it causes the food diaphragm to vibrate, transforming the signal into an acoustic output that can be perceived by the human ear. In order to better accommodate the interactions with sonic delights, we designed a vessel that encloses the extra wires and components. After testing multiple food materials, we found the rice crackers proved to be the most optimal material for sound emission. From our design practice, we identified 3 key principles for material selection. First, optimizing sound performance with ultra-thin, lightweight, rigid food materials for effective vibration. Second, maintaining palatability with a neutral taste and pleasant texture. Third, ensuring flatness for gold leaf by using stable, low-wrap material and precision fabrication. Regarding the gold leaf, another key component of a food speaker is the voice coil. In our design, instead of embedding traditional metal components, we designed 2 groups of edible coils. Group 1 featured traditional configurations, while Group 2 incorporated experimental artworks. We conducted a simple sound quality measurement of our food speakers by testing all coil designs. We found the design variations can affect audio outputs, like volume at specific frequencies. However, these differences did not translate into significant perceptual changes for the human ear. Also, we recognize that the coil designs play a role in food presentation, potentially enhancing its sensory appeal. This interaction between visual and auditory stimuli has been further explored in our study. To investigate how people experience food as a speaker, we conducted a study with 10 participants, guiding them through 3 activities. 1. Eating a regular cracker with background music, followed by eating with sonic delights while listening to the same music. 2. Eating with sonic delights featuring different coil designs. 3. Selecting their own music and eating with sonic delights. Afterwards, participants took part in semi-structured interviews. The sessions were audio and video recorded, then transcribed for thematic analysis. Through our study, we uncovered 5 key themes in how people interact with sonic delights. First, the interconnectedness reflects how blended sensory stimuli shape perceptions and identity in a unique way. Second, the aliveness highlights how the vibrations and haptic feedback of sonic delights created a lifelike experience. Third, the exclusivity reveals that the soft sound fosters an intimate, personal connection with the food. Fourth, the wholeness demonstrates how a fully integrated sensory experience creates a holistic, immersive appreciation like eating a piece of art. And finally, the empowerment shows that the participants felt in control of their sensory experience with sonic delights. Based on our findings, we identified 4 key takeaways to unpack the implications for future design. First, we envision turning food material into interactive, edible computers, creating dynamic and responsive consumable experiences. Second, by synchronizing different modalities, we can enable real-time customization, enhancing both engagement and sensory research. Third, blending food's physical qualities with digital enhancement will create new ways of multisensory interactions. And last, the interactive food takes on lifelike traits. We must carefully design these experiences to evoke the right and meaningful emotions.